So, hello everyone. I'm Theodore. I'm currently working as a software engineer in an applicant tracking system called Workable. You can find me online under the nickname Vorillas. And I flew my way here from Athens, Greece. Actually, from the very same neighborhood the current NBA MVP player Giannis Antetokounmpo was born and raised. So today, I'm super excited to be with you because I have the chance to talk to you about one of the most interesting projects that I have ever had the chance to work with. So today, we're going to talk about how JavaScript and accessibility can be used in real-life situations. Before we start, though, it's really important to take a step back and take a look how our community has evolved over the past few years. We are extremely blessed to have so many great people among us, people that have actually broadened our aspects and our vision so we can talk beyond code. So we can talk about human rights, about inclusivity, and more often about accessibility. So what's accessibility all about? If we take a look at the dictionary term of accessibility, we will find out that accessibility refers to all these actions we have to take in order to create products, environments, or systems accessible to everyone. As far as we're concerned, though, as software engineers, web developers, web designers, we are mostly focused into creating accessible communication systems. Like, we want to communicate with our end users, so we are using semantic HTML. We are integrating external software like screen readers or external hardware. You will be fairly surprised, though, if I tell you that the very first accessible communication system was introduced nearly 200 years ago. So this is Louis Braille. Braille was born and raised in a small city outside of Paris in the early 19th century, and as a child, he suffered a terrible accident that left him completely blind from both his eyes. But still, he has managed to excel his education and finally got accepted at the National Institution for Blind Youth in Paris. It was back then where he found out that the reading and writing system used by visually impaired people back in the days were, how can I say, a bit absurd. So people were using brushstrokes, trying to create embossed letters, trying to recreate the alphabet used by the sighted people. So at the age of 15, he created the famous Braille system. Braille is a tactile system. It's actually the very first binary encoding system ever made. So we can actually say that Braille was the great-grandfather of computer science, right? Usually Braille comes into a shape of 6 positions, and Braille system encodes characters, letters or symbols using combinations of raised dots and spaces. In its very first form, a slate and a stylus were used in order to allow people writing in Braille. So the readers can use their fingertips, trace down the letters, combine them, creating words, sentences, and so on. Braille system was good. It was actually so good that hasn't literally changed since its birth. As we speak, Braille is translated in more than 200 languages, and it has found applications from math to music composition and so on. Okay, so soon after Braille's death, typographers used heavyweight paper and inkless typesets, and books in Braille start getting out in public. Soon after, in the early 20th century, typewriters were invented. So modified Braille typewriters provided the users with a semi-automatic way of writing Braille. By the way, the happy typing lady you can see in the video, this is Helen Keller. Helen Keller was a famous American author, an activist about human rights for people with disabilities, and also the very first blind deaf person that has managed to graduate college. Back in our storyline, the last piece in our puzzle was introduced in the late 1980s, 1990s. So these retro-looking devices are called refreshable Braille displays. As you can see, on the bottom of the device, there are like a fixed set of Braille cells. Braille characters are also known as Braille cells. So the users can load text, or they can pair these devices with external hardware like laptops or mobile phones. So let's recap. The year is 2019. Organizations and individuals are raising concerns about literacy rates all around the globe. We have the tools, we have the assets, we have the mindset, we have a system that actually works for so long. So someone could say that we're in a really good shape, right? Well, actually wrong. Numbers and statistics are heartbreaking. According to the World Health Organization, 253 million people are living with visual impairment all around the globe. Most of them are suffering poverty or living within war zones. Only 10% of these people can have access to the appropriate education material or even a chance to get a job. And someone could say that we cannot relate with these numbers, right? So we're talking about developing countries, or I don't know, people living in Syria or Libya, right? Bear with me for a moment. According to the National Federation of the Blind, 90% of visually impaired children living in the States are not capable of reading and writing because they're not being taught Braille or given access to a proper educational material. Just to give you a perspective about how low these numbers are, I'm going to compare them against the literacy rates of Ethiopia. Ethiopia is a country that has suffered poverty and civil war for more than 30 years, but still, 50% of the citizens of Ethiopia are capable of reading and writing. The most important fact about these numbers is the fact that these numbers are increasing as we speak, year by year, but still, Braille literacy rates literacy rates for visually impaired people living in the States are stuck since the 70s. And we have to think ourselves, what did we do so wrong? So what actually causes this disaster? As a matter of fact, we're lacking of assets. So books printed in Braille are like super expensive. They cost 3 to 8 times higher than a regular book. And also, just 1% of the available books are also available for Braille. Refreshable Braille displays are like super expensive. They cost $500 to $8,000, depending on the number of the cells provided. And last but not least, typewriters are super expensive as well. And although the typewriting technology is a bit obsolete, people are still using them because they're like a more appropriate way and they provide the users with a more delicate way of writing Braille. And now imagine that someone hands you this problem like, you as a member of the JavaScript community, is there anything that we can do in order to help these people? When I first tried to teach myself Braille, I was stuck with this problem like a lot, and I keep thinking about it like a lot. So I have decided to try creating a device that could actually try to mimic how refreshable Braille displays work. So I wanted to try small, maybe starting with a single Braille cell, and maybe scaling up as my prototype could start taking shape. Before we start, though, we have to set up some goals, right? So since I had no prior experience with hardware or embedded development, I wanted my device to be as simple as possible. Obviously, it has to be accessible to everyone. And finally, I want to make my device as simple as possible. But how do we start? Is it even possible for software engineers like me to prototype a hardware device? Apparently, it is. We're going to accelerate our development process using a piece of technology called microcontrollers. So microcontrollers, for those that are not familiar with the subject, are like tiny computational units. They're usually coming into the shape of a board. They're relatively cheap and easy to get your hands on. Arduinos, Raspberry Pis, Photon, just to name a few. So for the purpose of this experiment, I have decided to stick with one of the most famous ones, the Arduino Uno. I purchased mine online from like a couple of bucks. As you can see, the board has pins popping out from the device. So labeled with numbers. So we can actually expand the functionality of the board just by attaching or detaching external modules, sensors, and so on. So for the purpose of this experiment, I wanted to start coding and experimenting. I will try the Hello World project of hardware development, like flashing an LED light. So I have attached an LED on the pin labeled 13 and the ground just to power up the LED. But how can we code a development board? So the Arduino comes with an IDE called the Arduino IDE, obviously. And we can use C code just to write code for the device. A simple piece of code for flashing the LED would look like this. So we're initializing the pin labeled 13. The Arduino has some built-in functions, like the setup function, so we're setting the appropriate pin as an output. And it has also a loop function that runs all the time. So we're gonna flash the LED high and low using a delay of 500 milliseconds. And that piece of code actually works. But as I was trying and experimenting with different modules, and I was trying to integrate my device with maybe a web interface, I found myself stuck. Just to be honest with you, I haven't written C since my college years, so it was really hard. And luckily, though, I stumbled upon a project called Johnny 5. So Johnny 5 is an IDE and a platform developed by a Canadian company called Bocoup that allows us to write JavaScript code, Node.js code for microcontrollers. In some cases, like the Raspberry Pis, we can create standalone prototypes. In our case, using the Arduino, we can actually remotely, Johnny 5 creates a thin client, so we can actually remotely control the device from our development machine. And we can actually rewrite the flashing example, the flashing LED example, just like including the Johnny 5 module, initializing a new board, and using the callback when the board is ready, we're gonna flash the LED using the blink LED function. And I can barely hear some of you whispering, what's wrong with this guy? Why does he want to write JavaScript for a freaking microcontroller? Okay, when JavaScript was born, the implementation was, how can I say, a bit naive. So we used JavaScript as an event-driven programming language. And this thing actually works. The same concepts work for microcontrollers. You're gonna integrate external components with your device. So you have to listen for buttons clicking or flashing the LED and so on. And JavaScript feels way too natural to program these boards. Also, you can use the registry. We can use whatever is on the registry and enhance our development experience. So we can use loaders for utilities. We can use the Bluetooth API, web service, whatever you can imagine. We can bring the same experience from the web to the microcontrollers. Also, portability, it's a real thing. So even within the same family, like the Arduino family, we have different software and hardware specs from device to device. So the Arduino Uno is totally different from the Arduino Nano, the Arduino Mega, and so on. But we can use the same code for different devices, and that's actually awesome. And finally, least but not last, we have to admit that it's in our DNA. We are trying to run JavaScript actually everywhere. So we want to make developers have, using JavaScript, giving them the ability to actually create products from the web, for the server, for mobile devices, smartwatches. So why not giving them the ability to run code for a microcontroller, right? And next up, that was a really rough period. I had to teach myself using something like a 3D design software. So that piece of hardware that looks like a block of lasagna, that's a Braille cell. My original idea, please don't judge. So my original idea was that I could somehow create individual Braille cells that could be easily attached or detached with the device. Since this was a prototyping period, I used my own 3D printer, so it was relatively easy to design something, evaluate the design, and keep the process going on. And finally, we have to think, how are we gonna actually pop a pin? How can we translate data to motion? So as I kept experimenting with different modules, I have decided to stick up with this little fellow. This is called a solenoid. So solenoids are like tiny push and pull actuators. They have a tiny electromagnet inside. They are actually used for watering systems or electronic locks. So using 6 solenoids combined, I can create a Braille cell since there are like 6 positions per cell. I purchased a bunch of them for like a couple of bucks online. And finally, we can bring everything together. So first things first, we have to think how we can actually encode text to Braille. So taking up the alphabet, numbers, and symbols, as you can see, we're going to allocate an array of 6 positions. So zeros stand for idle pins, and ones stand for raised pins. Unfortunately, the Braille alphabet is not deterministic, so we have to actually create a map of all the available characters, letters, and symbols. And afterwards, we can create a symbol utility function that takes up a character as a single parameter and turns the Braille representation. Next up, we can create a really simple class. That's a cell class. In the constructor, we are using the allocated pins, so we want 6 pins from the board in order to control each solenoid. So we're using 6 pins as an argument for the constructor and the Johnny 5 instance. And finally, using a private method that accepts a single argument, we can loop through the array of the raised and idle pins and decide if the pin is up or it's down. So this class is stateful, so we don't have to reset the pins each time the characters change. And finally, our main product would look like this. So we're including the Johnny 5 module, we're including the cell class, we're initializing the board, and when the board is ready, we're creating a new instance of the Braille cell using just 6 pins as arguments, and finally printing out the character A. So I think most of you are quite bored right now. So why not bring up a live demo for you? OK, let me break down the slide a bit. So as you can see, I have live feed from my camera. Just to be honest with you, this is my very first time in the States, and I got really scared of getting detained at the airport, so so I had to break down the device, and I just brought with me a single character. So my entire presentation runs using JavaScript and HTML in my browser. So I have a live feed from my camera on the right side. On the left side, I'm using a brilliant typeface called Braille Neue, which will give you a visual representation of the characters printed out. And using the input text field on the top, I can write something and print it out from the device, just like that. So let's try to write something meaningful rather than hello world. OK. Cross your fingers. Thank you so much. So apparently our prototype works. It works every single time, I promise you. So let's bring up some results. As you can see, I had no prior experience with embedded development, but the embedded development family as well as the JavaScript communities are really helpful. So building up this device was relatively simple. No sophisticated coding, no sophisticated modules. Everything was purchased from online. So we can say we have achieved that goal. Next up, we can actually expand this device. So based on the number of pins provided by the device, we can attach or detach Braille cells on demand. And finally, we can bring up to 12 cells just for $40. So we have to think ourselves, what's next? So as we speak, I'm trying to improvise the device. I'm working on the second version. And I'm trying actually to improve the design and get feedback from study groups, from people that could actually use this device in order to learn Braille. Also, solenoids are good for prototyping, but they're a bit clunky, and they're energy inefficient. So I think we can improve the design using a piece of module called microsteppers. These are tiny stepper modules that are used in controlling camera lenses or DVD drives. So we can actually recycle old parts and improve the design using a bunch of them. And finally, using microstepper modules, we can actually reduce the cost of the actual device. Finally, I think that people can use this same piece of technology and create their own devices, like creating something like a weather station for people that need to know the weather using sensors, modules, and so on. And actually, we can go beyond Johnny 5 and try different frameworks like the Arduino one, which is actually a project that runs JavaScript in the microcontroller. And for the past 1.5 years, I keep talking and presenting this device to people. And I keep thinking, I have different talks with some colleagues of mine, people that I meet at various meetups and conferences. And I have thoughts about maybe trying to seek for funding or raising a crowdfunding campaign, because I want more people to have the ability to use this device and actually help people. But instead, I want to ask for your help. So the entire prototype is open source, and you can find it online. You can actually build this device for yourselves. I think it's a great project to get you started with the IoT world. In the upcoming months, I'm planning of delivering the very first open source Braille printer that runs JavaScript as well. So we're experimenting with some wearables, so great things to come. And I actually think that we, as the JavaScript community, we can do more. So somehow we do actually care, and we are now openly speaking about things that actually matter beyond the digital world. And if there's something that you can take away from this presentation, is the fact that we have power in numbers, and we can actually raise awareness. And at the very end, we can somehow affect the world. Thank you so much for your time and patience.